have you been doing any FPGA development lately? If you have been, probably you've already realized that the environmental setup and toolchains is such a pain. So to make it simpler, we have this compiling as a service platform. The domain name is caas.symbioticeda.com, and here you can just edit all of the code in the browser. And after the coding, you can just press one button to submit this code to our server, and our server will compile everything for you. And after this, you can even use our web USB based OpenFPGA loader port to directly program this bitstream onto a board you have in your hand. Just everything happens in the browser, so you literally don't need to install any environment on the host computer. Let's have a demonstration. So first, depends on what board you have. Like here I have a very classical icebreaker, and we already have an example for that. You just click the template and go to this icebreaker, and you see these FPGA parts or toolchains, and the module names are already set, and you have this files automatic load here, and then we just need to press the submit. Is this faster than you thought? It has already finished, and you can see the log real-time rolling here. Okay, then it's time to power on the board and program the bitstream using this web USB based loader. So you see now like there are some default bitstream inside, but it doesn't matter. We just connect local USB, and from here we know that this board it will be this dual RS232HS. We just connect it, and of course usually we can use this detect FPGA to get something, but since SE40 series don't have a JTAG interface, we're gonna just program bitstream. I see that there's an error, but it's written very clearly that we're gonna need to do something with this FTDI cable. On Mac it will work out of the box, but on Linux and Windows we're gonna execute these commands to fix things. It has already been listed here, so we just copy it and run in the terminal. Okay, so the default kernel driver has been removed, and we have another try. You see it's working? So the program bitstream has finished, and we saw that on the upper right corner there are two LEDs blazing, a red one and a green one. So of course we can just edit the code whatever and do some random changes. Imagine let's just make this smaller and have another try. I can't see much of a difference, huh? I guess we can try things like specifying this to 0 and this is 1. It's finished the game. And this time you see like only the green LED is on, but the red one is not on because it's negative. If I do the reverse and have another try, I can see the other LED is on. So this iteration using this platform can be very fast. Now let's try something more powerful maybe. I have here a Vigilant Basis 3 board. and everything is all the same with this as well. You can see still there are some default bitstream inside, but it doesn't matter. And this time we select a example design for it. We have the first example as Digilent Basis 3 Blinky. Everything is the same. We just submit. So even on a Xilinx 7 series, the compilation is still very fast. This FPGA do have a JTAG interface, so you can detect FPGA. First we should select the correct USB device, this Digilent USB device, and detect FPGA. Seems I need to do this again. Because like on Linux, every time a new USB device is plugged in and it's a Digilent device, this module will be reloaded. So if you want to make this permanent, you can edit those configuration files to blacklist this model, but by that way you lost access to like Vivado or some other tools, so I just prefer to do it every time manually. Yeah, we saw this FPGA being detected, RTX A7 35T, and we program bitstream. Yeah, you can see the demo is loaded correctly, and this is exactly what our code is doing. Like for the upper part of the LED, it's just behaving according to the switches, and for the lower part of the LED is a counter. Now we can just modify this, like we make the counter much faster. You can see it is loaded, and we have a blinky. It is so fast that on a lower bits it's acting like we cannot see what the real blinky is. But on the top side we can see it's a binary counter moving quite fast. So that's what our code is asking to do. Yeah, so basically that's the basic usages of this compiling as a service platform, and probably I'm gonna make some other videos to introduce some of the other usages as well, like simulation and API access. Thank you for watching.